This video covers problem number 8 on the second Physics 240 exam of winter 2013. The problem reads, a galvanometer has a coil resistance of 100 ohms and requires 1 milliamp for full-scale deflection. To make this galvanometer into an ammeter reading 200 milliamps full scale, we need to connect a resistance of blank. So since we're trying to create an ammeter, we want as little resistance as possible so we don't disrupt the current. So that means from this equation, we want to add a resistor in parallel, because that will always decrease the total resistance. So right off the bat, we can eliminate answers A and B. Next, we want to draw the circuit. We're given that the resistance of the galvanometer has 100 ohms, and we know that we're connecting it in parallel to a shunt. So we'll call that RS. We also are told that we want 200 milliamps to deflect this full scale, so we have 200 milliamps flowing in. We're also told that 1 milliamp deflects the galvanometer full scale, so we can go ahead and use the junction law to find out how much current will be flowing through the shunt. It'll be 200 minus 1 would be 199 milliamps flowing in this direction, or to the right. We can then go ahead and use the loop law. So if we imagine a loop going around this direction, we know that the total voltage should be 0. So this is with the current, so we have negative the current of the galvanometer times the resistance of the galvanometer. We're going back around, which is against the current, so it's the opposite sign. So we have the current of the shunt times the resistance of the shunt should equal 0. We can go ahead and rearrange that for the resistance of the shunt, which is what we're solving for. Throw in some numbers that we're given, and go ahead and solve and find that the answer should be 0.5 ohms. And again, we know it's in parallel, so the answer is C.